CCNA2, RSA, the big one. This one will actually grade itself, unlike if you had to do my other ones. Alright, see the completion down there? Alright, we'll see if I can get to 100. I'm going to go put this over here so I can read it. And yeah, this is fancy looking, isn't it? Okay. That's what we're going to do, but what are we going to do? Alright, building 1. Oh, gotta get that console out. And so, building 1. Terminal. Configure initial interface configuration. Yeah, I'm going to the chart. And then I'll come back to our friend. So I will name it. Host name BLD 1. Okay, then we're gonna say interface S0/0/0 IP add 192.168.10.105 255.255.255.252/30. I put period right here. It's actually the problem. There we go. That's that interface. No shut. Interface G00. No shut. We're going to do router on a stick. So now we say interface G00.45. I'm going to assume they're going to keep the VLANs close to the label of the subinterface. Remember, you don't have to. So I say encapsulation.1Q45, and then I'm going to put it into IP address 192.168.45.1. Wait, 0? No, 45.1, 255.255.255.0. Okay, so then I'm going to go to subinterface 47. I'm going to up arrow to my encapsulation, change it to be associated with the VLAN 47, and then change my address. What does it say? First one, right? Okay, we're good there. Then I'm going to say my last one, which is 101. And I'm going to encapsulate it for 101 for now. We'll see what happens later. And do the 101 network. And it is the first address as well. Alright, so we have that. I'm going to save that. I'll move on. Keep that there. Main. Got a console in there now. Get my computer screen back up here. Terminal in. And on main. Got enable. CompT. Host. Main. Interface S000. No shut. IP add 192.168.10.106. It's the other side of what I did on the other one. 255.255.252. If you didn't see that, that's what the command looks like. I'm going to do it again. Interface S00/1. No shut. And we're going to go 192.168.10.13. 113. 255.255.255.252. Didn't put an IP add on it. Alright, so and then interface. Oh, well, we get a lot of serials in. No, just one more. S01. No shut. And this one actually isn't a /30, it's a /28. So, I don't know. That's bad because I got that. Alright, so Now I'm back to here. I'm going to make this a /28, which if you do your math is 240. What is... I want the first IP address. Oh, this is an internet one. 198.151.100.1. Okay, yeah, I turned that one on already. Alright, so now we go into interface G00 and we give it a 248/29 and we go 192.168.18.41 wants the first in the address according to the routing table. Alright, so then we're going to exit there, save this up, good to go, and hit building 2. Oops. BLD2 host name right there. Interface S000. We're gonna go no shut 192.168.10.124. Have we used the 124 yet? No, we were in the 112 on that other one. So 124. It's a second address though. Alright, so we don't get to choose 10.124, so the second one would be 126.255.255.255.252. Forgot my IP add. Oops, forgot it again, just put IP. Alright, so then we go into interface S00/1. And we already used this one on the other one, so we have to do the second address on it, 192.168.10.113.255.255.255.252. No shut. Alright, I'm going to save that. Good there. Now we're going to get our management VLANs on our switches here. Interface VLAN 101 because it tells us to. It's going to be a management VLAN 192.168.101. Any address in the network. We've already used the 101. That's our router on a stick. It'll be our default gateway. We use the first one, so we're just going to use the second one. 101.2.255.255.255.0. And once again, I'm rusty on that. And then what we're going to do too is, while we're still here, I'm going to put my default gateway in. It's the first one of that network. If we look up to that VLAN, and so that one's in there too. And I'm going to move on. BLDG1-SW2 interface VLAN 101 192.168.101.3 255.255.255.0. Oh wow, did it again. And then I'm going to do an IP default gateway 192.168.101-1. Exit that. Save it up. There we go. And so I have that part. Now I'm going to pre-configure for address references. Alright, so we already have those. Now we can do the VLANs while we're in those switches, I guess. So I'm going to go back to this switch, pop that open, configure it, and so it says building switch 2, which is what we're in. Interface F03 is in switch port access VLAN 45. So we're going to put that there. Then it created a VLAN 45 for us. We're going to have to name this after this. Then we go to interface 21. And we say switch port access VLAN 47. Probably not a bad idea to just do switch port mode access right now. And then our management VLAN is in 101. We already know that. So I'm going to go back up to 3 and do switch port mode access as well. Now I'm going to exit this and do my VLAN names. VLAN 45 name records. Pop up there, do VLAN 47 name library. Alright, and then we do VLAN 101 name manage. Exit. Right, run to there. We're going to do our other switch. Put those VLANs in. Then go back to our startup config. Or the top of the page, I guess. I'm still on the charts. So I'm going to conf t interface F010 switch port access VLAN 45 switch port mode access. Then I'm going to go to interface F015 switch port, nope, that's service interface F0, I guess I put G0, F015 switch port access VLAN 47 switch port mode access, and then I'm going to exit VLAN 45 records, that's the name. And remember, we could build all these VLANs at once if we did a VTP setup, but we don't have one right now. VLAN 47 name library VLAN 101, nope, VLAN 101 name manage. There we go. Alright, so I have that chart then. Now what are these? Alright, so configure building 1 with the following. And now we get our names. Let's get in that building 1. Alright. Host building -1. Prevent the router from attempting to resolve command line entries to IP addresses. So that's IP, that's actually no IP domain lookup. Protect the privilege, and what that does is if we were to type something here like bug, it no longer will look for it. Prevent the router from attempting to we did that. Protect privilege exec with an MD5 encrypted password. Hopefully you guys know that that is enable secret. And I'm going to make my enable secret password 01. You know, best practice RS. prevent device status messages from interrupting the command line. That would have been nice earlier. And so we're going to go into line con 0 and say logging synchronous. That means that when we have something come up or down, like I'll show you, comp T interface, what is that serial interface on building 1, S00, shut, no shut, and I'm going to type. I didn't get the typing, but see how it puts it on an entire line instead of interrupting you like it was doing before. But hopefully you already knew that. So what are we doing here? Prevent the status message. Okay, have that. Secure the router. Line con 0. Password console 1. Oops. Login. Line bty 0/4. Password. We're gonna go SSH1. Login. Secure the router console and terminals. Prevent all passwords from being viewed in clear text. Alright. Service. Password encryption. Configure a message of the day. Banner message of the day. Banner. MOTD. Stay out of building 1. Oh yeah. Pretty intimidating message there. Alright. Configure the physical IP addresses. Alright, we've already put the IP addresses in. Describe the operation of building 1 serial interface. So that's just interface S00. Description. This goes to main. Use DCE settings where appropriate. We can do that if I do show run. Let's see. This one has a clock rate. Does our S00 have a clock rate? It does. So we're gonna do that. We say clock rate. Remember, this is the actual speed of a serial. It's only set on one side, the DCE. We could also find that by saying show controllers with the interface. And so we have that. Manually configure default routes to the internet. Is this on the same device? I don't know. Guess we'll find out if it's on the same device. Maybe it's on all devices. Manually configure default routes that use exit interface arguments. All hosts on internal LANs and campus networks should be able to reach the internet. It has been decided to use static routes to reach branch networks. Okay. I guess we're going to do IP route 0.0.0, 0.0.0. And we're going to do exit interface arguments. So there we go. We have that one. And then we're going to go into main. We'll check its IP routes first. Make sure we need it. And we do. So we say IP route 0.0.0, 0.0.0. What interface is that? S010. Come on. S010. Wrong context, forgot to go into configure terminal. So IP route 0.0.0, 0.0.0, S010. Is that right? Let's see, S010. Looks like it. That's our public IP address. Looks good there. Then it's been settled to use static branch networks that are connected to building 2. Use a single summary to represent the branch networks in the most efficient way possible. Configure the summary route on main in building 2 using exit interface. Alright, so let's take a little gander down here. And we have 192, 168, 200, 201, 202. So that's where it's changing, is in the third octet. So we know our network has to be bigger than a /24. 0, 1, and 2 are 3 networks away from each other. So a /22 would summarize all these. /23 would only get us to 202 without including it. It would include 200 and 201. We're going to use our lowest address of 200.0 and summarize. And so what we're doing is, remember, summarizing is like desubnetting. How do we desubnet these into one address? And so what we're doing is IP route 192.168.200.0, 255.255. What did I say? We have a /22. So it would be, I believe, 252.0. Exit interface is S001 on this one. Doggone it. Alright. So that's our main one. And then we have to go to building 2. And what we're going to do there is put that same exact route in, but with a different exit interface. We need a default route to the internet on this one as well. So first we're going to do that IP route 0.0.0, 0.0.0, and our exit interface is the local one. It's the same one on both of those. So we get S0/0/1 for our default gateway. And then our default route is IP route, or our summary route is IP route 192.168.200.0, 255.255.252.0, and those are X's. Doggone it. And our exit interface is all zeros. So S000. There you go. Save that up. They should get to the internet, except for these guys. Doesn't look like they're doing well. Looks like some switch ports are probably turned off, but we're good there. Alright, configure single area OSPF version 2 to route between all internal networks. The branch networks are not routed with OSPF version 2. Okay. So, start here, conft, what does it want us to do? Process ID, router, OSPF 10, and so do show IP route connected, because this is what we want to put in there. S00, we just did that. We know that that goes to the branch networks out there, so we're not doing those ones, so we're just saying network 192.168.10.112 with a /30, which is a 0.0.0.3 wildcard mask. We're going to put it in area 0, like we were asked. And then save that one. Move on to our next router. Oops. Okay, and also I'm going to see, because we have this one down, so I must not turn this on. G00. Comp T interface G00. No, shut. There we go. So now we're going to say router OSPF10. Remember, that doesn't have to match, but they've asked us to use it, so we're going to use it on all of them. Do show IP route connected, and so we're going to put all of these in there except for our public one. So network 192.168.10.104 0.0.0.3 area 0. And these are all serial, so they're going to be kind of easy until we get to one that's not. Isn't that always the way? So 112 network. Now we have to do a open. See there, we're getting an adjacency. Just going to press enter because it's the same one. But anyways, we need to move this to a /248, right, which is the /29. And so a 248 minus 255, what is that, 7? And so our network is a 192.18.40 with a /7. Okay. Oh wow, do we have some NAT right there? Is that NAT I see? Woo! Can't wait to do that. Okay, so back in here, terminal. Okay. Comp T. Router OSPF. EIGRP, no, router OSPF, EIGRP, router OSPF 10, do show IP route connected. We're going to turn this on. We're going to turn this on because we can't see our connected routes right now. I'm not trying to unlock that. Only some of them are shut down. Well, we're just going to make this easy on ourselves and do a range command. Interface F01 to 24. Forgot my range. No shut. And then we're going to go interface G01 to 2. Is that what they have on here? Yep. No shut. I don't know, we might want to shut down our unused ports in the future, but right now we're not going to. And we're still not up. Maybe I didn't turn this interface on. It's the G00 interface. Interface G00, no shut. What are you plugged into? G01. I could swear we just turned that on. I guess we didn't. There we go. Finally up. Finally up. Okay, so exit that. Router OSPF 10 again. Do show IP route. So we want all those connected. So we want network 192.168.10.104 0.0.0.3 area 0. Next one's /24, so put 255 on it. And see how that just went down? That's because we have, this is a 45, because we have logging synchronous on there. Next one is 47. And the next one is 101. I know they're going to tell us to shut these off, so I'm going to say passive interface G01, no G's, G00.45.47. We don't need routing information sent to our switches. They're layer 2 devices. They don't need layer 3 information. So that is why we're doing a passive interface on there. Customize, that's what we have next. Set the bandwidth of serial interfaces to 128 to K. Oh, great. And then set up, should have read this before. So I'm on building 1, and its router ID is supposed to be 1, router ID 1.1.1.1. We don't need to clear that yet, as it clears the algorithm. So after we get all the router IDs set, that's when we do it. Prevent routing IDs to be sent out LAN interfaces. We already did that with that passive interface. Configure SPF cost between the link of building 1 and main to do that. So we actually leave here, go into interface S00, right? I believe it's S00. Let's see what our routing table says. Yep. And we say IP OSPF cost 7,500, and then we also say bandwidth, because it told us to set bandwidth to 128. Bandwidth and kilobits. So 128 there. Jump into main now. So main, I guess we didn't advertise that. It's a college server, so it's not gonna matter. So we say compd router OSPF 10 router ID 2.2.2.2, and that's pretty good. Okay, once again, we don't have to do that till they're all set, but we want to go into all of our serial interfaces now. And we want to let's see, we're going to do show IP interface brief. Okay, so we'll just show IP interface brief. Alright. Now we're going to go config T, interface S00. What do we send to that? Bandwidth 128, interface S00/1, and with 128, I wonder if they do want me to do that one. S00, I haven't decided if we need to put that public interface. No, we don't, because we're going to NAT it. It shouldn't need a route. Into OSPF. But we'll still send the bandwidth to 128. Alright, so we have one router left to do for that section. It's locked. So, terminal. Building 2 has a router ID of 3.3.3. And so now we're actually going to do, but we'll go into interface. No, it has two. It has S00 and S01. 001. We have that part done. We have that part done. So now we're going to find and clear that out so it uses it. So we say clear IP OSPF process so it can rerun its algorithm. We say yes. And as you can see, the adjacencies go down and pretty soon they will come back up. Alright, so now it looks like we are on our switches. What is this? I can't see over there. Well, everything, hopefully we don't have to look over there for much because it completely disappeared on me. So, actually we're going to go into this switch and turn it on. Configure the names of the VLANs. We already did that. The names, VLANs should match the names of the VLAN exactly, case and spelling. Alright. Configure ports that link switches with each other. Ability 1 to function as trunk ports. Okay, so let's do a show run. Figure out why they have one shut off. Okay, it must be 21. Actually, it's probably not 21. It's probably a gig port. There should be another one shut off too. So let's see what it is. It's G00. Yep. Alright, so we didn't probably turn off that, but, oh, actually, while I'm in G00, let's, actually, I guess not. So, interface, G01, switch port, mode, trunk. There we go, but we still have one port down. Do show run. What port is down that I didn't see? That one's trunking. That one's on, must be at the top. F03. Turn it on to that computer. So once we get on here, we should be able to form a trunk on the other side until we figure out what advanced configuration options they want for it. Anyhow, Control-Shift-6, if you get that lookup, remember we disabled it on the one switch. T, interface G02, no shut, switch port, mode, trunk, and we're actually going to go into interface G01 and do switch port, mode, trunk. because yeah, we know that's going to be router on the stick, so we're going to have trunk up there too. So those should form. Configure ports, assign switch ports shown in the table. We did that. Address 101. The network indicator VLAN table. Note. First address assigned. Yeah, we get it. Configure all unused ports as access ports and shut down the unused ports. Okay, so the easy way to do that is show IP interface brief. Alright, and then we're going to say comp T and until 10 they're down, so interface range F0, 1, 2, 9, switch port mode access, shut down, or just shut if you can't spell down, like myself, and then so 10 is up and 15 is up. So we go interface, go to our range command, we do 11 to 14, switch port mode access, shut, and we go to our range command, and I think 16 to like what, 21, 16 to 24 down. Alright, so those are done. Now we need to go into the other switch, do the same thing. Do show IP interface brief. Let's see if we can do it before I set the bell. So we have 1 and 2 down. Port mode access. Shut. We're gonna go F02. Do the same thing. Now we're gonna do interface range. F0. Let's see. 3 is up. So from 4 to what? 21. And we're going to do a do show IP interface brief again. We want to see after 21. And so, oh, we actually turned 21 off, actually, so it should have been to 20. No shit. So we go interface F0, 22 to 24. Forgot my range. Switch port mode access. No, shut. They don't actually have us put in a black hole VLAN, huh? Anyways, that's for another day, I guess. So I'm going to save that. And then I am going to move back up to our switch. Our configure building 1 as a DHCP server for the guys under it. Alright, so there's two things I got to do. I need to get my router and a stick interface trunking on VLAN 1. So let's see, I'm console, so it's console 1 enable password 01. Okay, so comp T interface, what was my interface permissive? I think it was G00. Checking the chart here, it is G00. So we're going to make another interface, G00.1. We're not going to put an IP address on it, that's why it's not on the chart. So we're going to say encapsulation.1Q1, and this time native, so that it will trunk with our friendly switch down there. Now we're going to say, now we're going to look for our DHCP, and our DHCP says use VLAN 45 and 47 as pool names. Note the addresses of one should be reserved for static assignment of each pool. So that's the first thing I'm going to do. IP, DHCP excluded, address, and we're going to say, let's see, 47, I think, is it 192.168? Yep, 45 and 47 with a /24. But we're just going to say 192.168.47.1. That's our start. 192.168.47.25. Wait, does it say 2520? Sorry. And then we're going to do that again, except we're going to do it with VLAN 48. Is that its name? 45. I don't know why I did 47 first. Alright, so we've excluded those. We need to set our DNS at that address. Ensure your host in the link. Okay. Alright, so next thing is IP, DHCP, pool. And then this is our name, and so we're using VLAN 45. The network is 192.168.45.0.255.255.255.0. The default router, or the default gateway, is 192.168.45.1. And our DNS server we're using is 192.168.18.10.100, I mean. Okay, so that one's done. Went back out. Let's do a VLAN pool named 47, and its network is 47.0 with the same info, and then its default router is 47.1, and then DNS is the same as well. Alright, so that's our DHCP right there. We have trunks formed. We'll have DHCP on here now. Be scared. We haven't checked our trunks, so we don't know that they're working. But this will tell us, oh, there's our DNS, our DHCP. So that is working. So next step, configure NAT to translate internal private addresses into public addresses for the internet requirements. Alright, configure NAT to the college server. Okay, so the college server is on main, and so we will configure it. Which one does it want our inside and outside info addresses to be? Configure, translate the internal address to let me read this one. Okay, so we're kind of weird situation, because it looks like from the drawing that this server over here, we're translating it, translate the internal address of the server to the address of 198. Okay, alright, we'll do it. That's weird. And we're configuring terminal. We'll say IP NAT, inside source static, and our inside source is 192.168.18.46, and our outside is 198.51.100.14. Okay, so then we need to go into, does it tell us? Let's see. This would be our outside interface, so that is serial 010. IP NAT outside. And then for that one, this is, it's G00. It is. So G00 is where we're translating it to. I'm going to save that. We're saved there. Alright, so next, use the addresses remaining in the public 192.198/28. The first two addresses in the subnet have already been assigned to the main ISP. Also, another address has been used in the static mapping in the step above. Okay. So we need to do everything except, what is this? Because I can't even see it because of this thing. Doggone it. Let's make sure. Wait, it told me. I guess it's 14. Alright. So, in the /28, 14 would be our last address, right? Because we have 16. Okay, so the first two and the last one we can't use. I'm not clicking on them. Man, that is annoying. Okay, so CompT, IP NAT, we're setting up a pool. We're doing a, so this is going to say, what are we named it? Internet. Okay, and start IP is going to be 198.51.100. We've used the first two, 1 and 2, so we're doing 3. Our finish is 198.51.100.13, and our subnet mask is a 255.255.255.240. Except you need to put net mask. Alright, so we have that part. So the next thing we do is we need to assign an access list of 1, because we'll link them together after that to do this dynamic net. So hosts on each internal LANs shown in the topology on the branch network should be permitted to use NAT addresses to access the internet. Use the source list of 1. Okay. Okay, so we're allowing who? Internal LANs, host on each internal LAN. Okay, so not the branch offices is what I'm hearing. This means VLAN 1. So the other one must be our manage IP address for Telnet and SSH on those SPIs. Okay. So we say this is just a numbered list, access list, permit 192.168, 45.0.0.0.255. Then we're going to do 47, and then we're going to do 101. And oops, we're not done yet. So now we link them together to get dynamic NAT to work. IP NAT inside source, and we say list, the list name, we say pool, and the pool's name was internet, and we're going to overload it because it told us to. Alright, so now we have to put an inside. We already have the internet interfaces outside, but the serial feeding down needs to now be an inside, so it's S00. 0. IP NAT inside, exit, exit. I can't test this. There's a server over there which would start NAT up to test this. Currently I cannot test it because of can't see them. So my packet tracer bug is not helping me out. Alright, so ACLs, everybody's favorite. Okay, so restrict access list to VTY lines of main. Okay, comp T, line VTY, 0 space 4. Wait, no, we'll make the access list first. Create a named standard access list. Alright, IP access list standard using the name manage. Manage. Allow only test hosts to access the network. Do we have a list, or is that somebody I can't see? Test host 203 host 203.0.113.128. No other host, including internet host, not visible, should be able to access the line. It should consist of a single line. Well, wait. I don't know why it's... oh no. Okay, so host main. Thought I wanted a different command, so we're going to go back to our IP list standard. I forgot permit host. Actually, we'll just do that again. Permit host. It changed my name to that IP address. Permit host. Alright, that's all we need on there. And so then we go into line VTY 0 space 4. Create an ACL. Why do we only want test host to be able to access the line VTYs of there? Alright, whatever you say. So we say access IP access class and the name, which is manage. And we say in or out. I'm just going to say in. Okay. So that one's done. Actually, let's try it out. No, it should be in. Okay. So, anyways, so we're done there. WR. And so our next list is allow access to the college server while controlling other traffic from the outside. Create an ACL is just okay, so we're doing a numbered ACL, so access list 101, it's extended. First, allow test host full access to all network hosts and devices. Permit 203, and I don't know, maybe this test guy is something else, but that's all I see is 203. Now permit, we're going to do the protocol. You could have done a question mark to know that. 203.0.113.128. I messed this thing up again because it's host. Permit host, so only this address to anybody, any, and that's that line. And so now we're going to do another line. I don't know what it is because I'm scrolled up on my thing. But okay, where are we? Access list. First allow, then allow outside hosts to access the college server. That's really difficult. What do you mean outside hosts? Alright, so we're just going to say any permit TCP any to host 192.168.18.46 equal to, we could either do www or we could do the port number of 80. add a statement so that all denied traffic will be shown and show access list command output. Alright, so this is also where we could show it in logging. So our final command for this is actually an oxymoron, and it's deny. Deny IP any log. No, it's not going to work. Deny should be okay. So what does it want us? Add a statement so that all denied traffic will be shown and show access list commands output. No, actually we don't have to do logging on this. Show any because then it'll show how many it matches. Deny IP any. If we did TCP, or if we're in real life, we could put it on logging and it would show as a syslog message. Your ACL should have 4 statements. Allow traffic. Oh, allow traffic that is in response to data. Oops. Screwed this access list up. So we have to. We're just gonna delete the whole thing. No access list 101. Okay, now start over. And so first we do this one. Then we do our web traffic one. Then it says allow. So we're going to say access list 101 permit TCP, because that would be the protocol that sends requests. And we're going to say from what network though? Oh, we should have 4, so we're just going to do both 192.168.47.0 to any established permit TCP. Oh, I forgot my subnet mask, or my wildcard mask for this 0.0.0.255 any, and then we just say established. Okay, and then our other one will be for 45. I probably won't get credit because I did them in opposite order, but I don't care. Yep, it's not moving alpha 93. And then we do the deny statement, the oxymoron deny. So what that does is when we do show access list, it would actually show how many is matching, that is doing that rule. Now we need to place it, so I wrote it for our internet interface, and so I'm going to go conf t s010 and let's see. So if the source, actually wrote it backwards, I think. Let's figure out how I can place that. So this traffic would be coming here, so that's outbound on that interface. So it says any traffic to inside of here, that would be inbound. and then it says permit the source. So maybe I wrote this one wrong. So we'll just redo it again. I need my permit for 203. There it is. That one was fine. One right before 203, I need to switch it because the source. No, the source would be. Yeah. Because I'm going to place it outwards facing. So probably not what they want me to do. And I'm actually going to say it's outwards facing. No, that one's bad too, if it's outwards facing. Oh, so close to the source as possible is where we should be, but the source is here and here, so this is definitely where we have to place it. But I am writing that ACL, and alright, so I think is it any TCP any if it's outgoing. Source would be any, yep. And it's coming. No. Maybe we want to write it incoming. Alright, that's what we'll do. We'll just rewrite the bottom ones. So TCP any to host 198.151.100.14. Okay, I'm going to do that one. Then my next one, I'm actually going to, let's see, permit. Let me read that again. What does it say we need to permit? We need to permit inside. Allow traffic that is response to data requests from. Screw it. We're just gonna go any stat. No, we need IP. IP. We need TCP any established, because that's the only way we're gonna cover it. That many, because then we need a deny IP any to see what they want there. So that's what we're doing. And then we can do interface S010 and place it for, let's see, our source is any, our destination, that's incoming, our host is incoming, okay, yep, so our access list can be placed incoming at this point. So IP access group, what do we call this, 101 in. Right, so what I'm debating right now, what was bothering me is that if you go outbound, the source and destination changes, right? So this first thing is the source, the second thing is the destination. So if you write it one direction and place it the wrong direction, it doesn't work. So remember, incoming is before it gets routed. Outgoing is it's already went through the router, is going to be routed. So that's got to be the best placement, and that's the best I'm going to do with that one, at least. Cheat it up if you can't figure it out. Alright, use the VLAN numbers for required interface numbers. Use the first address. What? Use the first addresses in VLAN networks for interfaces. Already told me that. Okay, we did that already. We have inter VLAN. Test and configure. Alright. So, can't test my NAT. Maybe that's why they're punishing me, but it says I have a 94% now. If you get close to that, hey, I'll give you full credit. Actually, I mean, where can get 96, or tell me what I'm not matching. It's probably some kind of capitalization or something. Anyways, that's the video. That's RSE, and don't worry, they only get longer from here.